Christensen. I'm the President and CEO of the Alliance for Water Efficiency, and we're very pleased today to offer a webinar on our Financing Sustainable Water project. We have recently launched our work products in this initiative, and we're very pleased to be sharing them with you today. Next slide. So just a few little background tips on the webinar. The webinar will be 60 minutes, well actually it'll be 90 minutes in length. So that's a little error in the slide. We will be going a full 90 minutes. The audio will be through your telephone or through our computer microphone and speakers. Either way, you will be muted because as I discussed, we will be recording this presentation so that others who are not able to join us during this time slot can listen in and see the material. However, that shouldn't discourage you from participating in the webinar. We have a chat box which can be activated during the entire session. If you look in your upper right-hand corner of your screen, you'll see a little orange box with a white arrow. And if you click on that white arrow, it'll open up a dialog box from GoToWebinar, and you can type your questions from this point forward. And we will be taking the questions more or less in the order that they were received. We'll probably let Jeffrey group similar questions together, but we're looking forward to a very interesting discussion after the presentations, and we're hoping you'll participate and give us some questions. Next slide. So to introduce you to the folks who will be speaking, in addition to myself, we have Dr. Thomas Chestnut from A&M Technical Services. We have Bill Christensen, our program planner at the Alliance for Water Efficiency, and Megan Sherry, our Special Projects Manager at the Alliance for Water Efficiency, who we will talk about all the individual pieces of the project. Next slide. So let's just do a little bit of background intro. Let's talk about the utility financial management issue and why it's becoming harder than ever to plan for stable revenues in our water utility systems. Next slide. Here's a chart that I stole from the National Association of Water Companies. I like it because it's simple and direct. And it shows from 1972 to 2010 the decline in water sales, annual residential gallons sold per residential customer. And what this really is demonstrating pretty clearly is that the straight line extrapolations of demand that we had come to expect in the past are no longer what we're all calling the new normal of demand in water utilities around the country. Next slide. From our perspective at the Alliance for Water Efficiency, this is actually a good thing. We have the highest per capita water consumption in the world. But reducing demand from a variety of reasons, while it's a good thing for our water resources management, it does have side effects for the water utility financial planning. Because lower demand means reduced sales revenue, and that sales revenue has an impact on the utility balance sheet. It can mean not fully collecting fixed costs that are necessary to reimburse on an annual basis. We have short-run variable costs that are associated with delivering water, pumping that water, and the energy associated with that pumping, and chemicals for treatment. Those are all short-run costs that are associated with each gallon of water delivered. And then we have long-run capacity costs, which are often debt financed and part of debt service payments, that deal with water supply transmission, storage of water, treatment of water, both on the drinking water side and on the wastewater side. So when we're not collecting the revenue to meet those fixed costs, there's a problem. And so revenue stability, therefore, becomes an issue. And in that revenue instability, conservation is often blamed and is often the scapegoat. Next slide. But there are many different factors affecting revenue stability. It's not just the active conservation programs. Demand's been reduced from a variety of different sources. We've had plumbing codes and standards in effect starting in 1992 that have meant efficient fixtures were only available for purchase now in the marketplace. And as consumers replace those fixtures through regular remodeling and changeouts, those fixtures were now using less water. Yes, we have active conservation programs, but and the savings and reduced sales from those programs need to be planned for. But then you have other factors that affect demand and reduce demand. It can come from economic factors like a recession, which impacts business, commercial, and industrial water users, homes that are foreclosed or empty or not using water. So economic factors such as the Great Recession had a very dampening effect on demand. And then weather has a dampening effect on demand. You have reduced peak demand in years of high rainfall, where irrigation systems are not drawing as much water and therefore producing as much sales revenue as occurs in dry years. And then another side of the revenue stability equation is the costs that go up. In addition to the fluctuating revenue, you've got increased infrastructure costs that are beginning to climb across the country, and rise in other fixed costs as well. Some of those are variable costs like labor, and some of them are fixed, but those costs are also increasing at a rate that is much higher than your typical inflation rate of the past. So those are all factors that affect revenue stability. Next slide. And so here's a chart from Jan Beecher at Michigan State University. She runs the Institute for Public Utilities. And this chart really shows the runaway increase in water and sewer prices. As compared with electricity in the brown line, you know, water and sewer rates are really climbing, and they're climbing much faster than CPI, which is shown in the dotted gray line. As a result, this trend, which was once bundled and much more closely tied to other utility costs, now water and sewer are standing out as a much higher rate increase in this sector than others. Next slide. So what does this mean? This means you've got a political reality that's very uncomfortable for most utility managers. We don't really like to revise our rates. We like our consumers to feel that we're steadily managing the resource correctly. We are able to keep costs contained. We're able to keep prices level for the consumer. And so it's very politically unpopular to say to the consumer, oh, we have to raise your rates. And so many managers and many elected officials try to do rate increases as infrequently as possible. Those ratepayers are also voters, so it's really not a politically comfortable thing to do to be raising rates. Even inevitable inflationary rate increases were not regularly built into rates, and they were often postponed until revenue collection became a crisis and the double-digit rate increase was necessary. And so in this political conundrum, conservation is often blamed for the financial challenges that water utilities are facing, even where there are no active conservation programs in place in that utility. I mean, demand is going down for all the reasons we've just discussed. So the message to the consumer that conservation makes rates rise is a very, very unpopular message to give to a customer. Next slide. So why is it unpopular? Because really it should be a positive message. Conservation should be part of the solution. It's a long-term cost reducer to the utility, and since the revenue loss can be due to other drivers, it's not fair to just blame conservation for the reason rates are rising. Every gallon of water that's saved is water that doesn't have to be pumped, treated, and delivered, and it's water that can be provided to serve growth that might otherwise require new infrastructure and new capacity that would be a whole lot more expensive to the customer if that had to all be built. So that's part of the equation that needs to be quantified, how conservation actually contributes to rate stability in the long run. Next slide. So one of the projects that we did was to work with the city of Westminster, Colorado. Citizens there were complaining, as citizens do in a lot of places, when they are being asked to conserve when rates are just going up anyway. So Westminster reviewed the marginal costs for their future infrastructure, which would have had to have been built if conservation had not been done. And they came out with what we don't find surprising, but a lot of other people did. Since 1980, conservation has saved the residents of Westminster and their businesses 80% in tap fees and 91% in rates, compared to what they would have been today had conservation not been done. And so this is the kind of analysis that we think is useful in the financing sustainable water discussion and why we decided to undertake this project. Next slide. So our Financing Sustainable Water initiative is one where we're striving to provide practical resources for utilities, and not just utility employees in finance, but those in engineering, in planning, and public affairs who have varying technical ability when it comes to rate setting, but who nonetheless are part of the discussion. So we created a handbook to explain key concepts, provide case studies, and implementation advice. We created a public rate domain model to show various different scenarios, and we'll be showing you what those are. And then we created some web-based resources to provide the latest research and information in one location. And we'll also be showing you that as well. Next slide. So the key concepts we are trying to show in all of these resources is the following. Revenue instability is a feature of all rate structures. This is not unique to the conservation issue. Revenue varies, and we'll talk about that in a little bit. The efficiency objectives of water utilities should be identified at the start so that it can be part of the discussion in rate setting. One size does not fit all. One rate structure that works well for one water utility is not going to be the answer for another. So we're not here to say, oh, we think you should do this particular type of solution because it'll help you be more revenue stable. It depends. And so we'll talk today about what that it depends means. We do believe that embracing the uncertainty that is inherent in rate setting will actually give you better decisions because you will factor in how you can deal with uncertainty and provide different scenarios for discussion. Better rate analysis requires good data. This is all part of it. Customer understanding and empowerment in the decision-making process is key to getting those rates approved. So we'll talk about that. And we'll talk also a little bit about sound financial policies that can support fiscal sustainability. This is all part of a total package. Next slide. So I'll turn it over to Tom Chestnut at this point, who will talk to you about our handbook and model entitled Building Better Water Rates for an Uncertain World.
Thank you, Mary Ann. Next slide. I'll be talking about a handbook and a model. This is the outline of the handbook, Building Better Water Rates for an Uncertain World. This handbook is broken into 6 sections that cover what we think are the most needed sections for a broad audience. It also has 3 technical appendices. Next slide. So what do water utilities have to achieve? The handbook and the model try to be very clear about the difference between what you're attempting to accomplish and the means by which you can accomplish it. The ends of water utilities are water services, reliable delivery of quality water, and handling wastewater, stormwater, and watershed management are roles that different combinations of water entities are having to take care of now. What are the financial means that utilities achieve these ends? These include being able to recover your cost in the short term and achieving resource efficiency both in the near and long term, and being fiscally sustainable, about which I'll say more later. Next slide. So why is this so hard to achieve? Why is this harder than ever? I have a very short list, laundry list, of constraints and challenges that include scarce water supply, rising and uncertain costs, regulations, and customer demand for a larger public role and more exposure for utilities. There's also increasing uncertainty in weather and economic factors and demand in changing customer bases. So I don't want a lot of hand waving. I need some very specific answers. How can I do a better job? How can water utility rates help incentivize efficiency, contribute to revenue stability, and support long-term health? So what are the details for designing and implementing efficiency-oriented rate structures? This is what the handbook sets out to answer. Next slide. So the questions that need better answers: in an uncertain world, what information would lead to better water rates? How can weather, including drought or shortages, or even external shocks, affect customer consumption? There are a lot of water utilities that were surprised and have been surprised in the past. We'd like to avoid this. Demand response: if I am going to change my water rates, what will happen to my demand? If the price of something goes up, most customers tend to use less of it. That's known as the law of demand. Drop pricing: when these shortages come along, how should I plan for water rates under that situation? This is not an if question in many places in the country and the world. It's a when question. Probability management: what is the likelihood of deficit and what am I going to do about it? Fiscal sustainability: what do these likelihoods look like over a longer time horizon? And affordability: can my customers afford water service? Next slide. There's a key cycle here. Just as there's a water flow, there's a flow of economic logic. Water utilities design their systems. It takes cost to run it and to build it and to run it. Water rates are used to recover some of those costs, which in turn have an effect on water demand, which in turn can affect system design. So it's important to understand how these interconnect. Next slide. The heart of the problem is that traditionally water rates have been focused solely on historic cost recovery. So that's only one of our objectives. When system costs change quickly and perhaps unpredictably, historical rates may not reflect today's cost consequences. Rates would not then give customers correct information to make consumptive decisions. Next slide. So the key of this is a balancing act for water utilities. You need to generate revenue in order to pay for prudently incurred cost. You also need to avoid resource inefficiency, consumptive or productive waste. And this needs to be sustainable over the long term, which usually requires some pretty good planning. This is not to say those are the only three. I've listed some others here. Water rates that are not accepted by your customers won't be in place long. Affordability, legality is a very good thing to have in hand. But I want to remind you, if you're the one doing the balancing here on the unicycle, the key thing to keep in mind is that if you look at the graph to the lower right, do nothing, your revenue requirement is the flat line there. If you do water use efficiency, you can actually reduce customer bills over the long term. So next slide. So what is an efficient water rate? To do that, you have to answer what conservation is and what efficiency is. Turns out there are different definitions of conservation that are used. Any reduction in human water consumption, you maximize that by getting rid of humans. Minimizing loss or waste, that is any water reaching the ocean or any other receiving body, and you maximize that by building as many dams as you can. I'm rejecting both of those simplistic definitions, and I'm using conservation to mean something no different than resource efficiency. So what is efficiency then? There are also simplistic definitions there. I list a technical definition as you'd use with a pump, or financial efficiency. Again, resource efficiency is cost and benefits more broadly defined, and TBL stands for a triple bottom line. not just the financial books, but also cost and benefits to society and to the environment. So conservation that squanders other resources is not very efficiency oriented. Next slide. So specifically, the water price should signal the additional cost of extra production, treatment, and delivery. That in turn provides the information basis for consumptive decisions to match production cost. If prices reflect cost, then resources are used prudently. Next slide. You need to understand this concept of a price signal is not having a single dimension here. Not only do water rates signal to customers the cost of providing water service, customers also need that information to make consumptive decisions. Customer consumptive decisions, in turn, provide a signal back to the water utility of the customer's willingness to pay for water service. And utilities need that information to make decisions about production. What production costs are justified, how much reliability to deliver, the level of water quality assurance. So, next slide. This entire handbook is set in the context not just of efficiency, but also sustainability. So keep that in mind, that this has to occur within practices of good financial management. Water rate setting isn't theoretical. It occurs with and guided by financial planning and financial policies. So I want readers to note that when they go through the handbook. Next. So the handbook sets out steps for building a better efficiency-oriented water rate structure, including being very explicit about what the rate-making objectives are. That in turn can clarify how to make better trade-offs. Determining revenue requirements, allocating your cost, which is a two-step process, designing the rate structure, evaluating the rate structure against alternatives, and then deciding on a rate structure with public input. Next slide. Key at the concept of this handbook and the model that accompanies it, and we have a screen capture at the bottom of the model, is that deciding on the rate structure requires some hard trade-offs among different kinds of objectives. I've listed 3 over here. If you look at the graph on the right, many water rate studies focus on kind of implementation feasibility. What is a change that could possibly work? The handbook emphasizes a more analytic path, looking at what the intended effects are and how you can make better trade-offs to do a better job of achieving your intended result. Next slide. So what are the issues and concerns with water rate structures? One, you need to be clear that users face cost consequences of consumptive behavior. Any water rate structure provides information on cost consequences. The question is, how well does that align with what the today's and, in fact, forward-looking costs are? It must also get at how long-term water use efficiencies, investment in that, can contribute to delivering better value for the same dollars. And it also has to handle short-term shortage management, how you minimize shortage costs. Marianne mentioned that one size does not fit all. There is not a single rate structure out there that's the magic wand. A single rate structure may not even work across all classes of water service. And if there are differences in your customer classes, that may call for differences in water rates. They can be potentially viewed by customers as punitive. Communication issues are key there. There's a complete section on implementation that addresses this. And you have to be aware of your customer's ability to modify their behavior and usage. Often targeted conservation programs, targeted water use efficiency programs, can help your customers adjust their water use to new conditions. Next slide. Affordability is a large and increasingly important issue. There was a fantastic report out sponsored by the U.S. Conference of Mayors and AWWA suggesting that a traditional definition of affordability used by the U.S. EPA could be improved. It doesn't, instead of a community-wide impact, perhaps the more important thing is how it affects low-income customers. So if you just look at a community-wide average, there's a flaw of averages there. So you need a more in-depth understanding of how it affects different customer classes and even individual customers within a customer class. We have a screenshot from the AWE water sales and forecasting model to the right that provides some metrics on this. Next slide. So it does give an introduction to rate setting. Here we have the different rate forms. Their qualitative handling of many different labels and flavors, some of which generate the same rate form. But it provides a review of this entire rate setting process. Next slide. It gives tools for evaluating and building better rates. Here we have the AWE sales forecasting and rate model on the right, but it also provides a self-assessment trying to define exactly what the problem is you're facing. There's an appendix on modeling water demand variability, also on modeling water revenue variability and customer bill impact analysis. So it provides technical background on that, and it also provides specific assistance in the sales forecasting and rate model. Next slide. So this is the self-assessment. How do you avoid revenue surprises? Part of this is defining what the problem is. Do you have a revenue surprise? If you go down below to identify the problem, is the problem on the revenue side that your revenues are too low, or is it that your costs are too high? And this is where efficiency can play a role in helping address and minimize whatever cost increases are going to occur. Next slide. The handbook addresses modeling water demand variability, and having knowledge of how your water demand varies is key if you want to understand how your revenue varies. It also can be a cost driver. In the short term, if your water rates change, how does demand? And if your water supply availability changes, how can that change demand? So if you have a drought situation, a dry spell, your customer demand may be high. That doesn't mean you're going to have the water supply available, and that's going to have a consequence on what water demand actually occurs and what your volumetric sales will be, and of course what your revenue will be. In the long term, capacity sizing can be vastly expensive. Building too much capacity can result in capacity that's never used. Building too little results in poor reliability and customer shortage costs. Now, does that have anything to do with sustainability? You betcha. Next slide. In particular, the sales forecasting and rate model embeds this concept of price elasticity, how your customers will predictably respond to changes in the real price of water. If you do your long-term planning based on a constant idea of demand requirements as opposed to demand that embeds customers' economic response, you see the top line would be the line where customers don't respond to increasing cost of water. That's not theoretical. This is an empirical fact. Water service costs have gone up in the last 2 decades, much faster than the CPI. The lower line reflects the demand that you would see if you understand what customer response is. Note that this is not recent news either. Next slide. Note that it's not just a revenue question. It's the difference between your expected revenue and the cost that you're going to have to meet. So if we take just a 1-year view of revenue volatility, being this difference between revenue and cost, net revenue. The big scary question is, if your water sales vary on a year-out basis, how is that going to affect your net revenue? Typically, the more revenues are collected on your volumetric commodity rates, and the more you do that, the more potential there is for volatility. There is an exception there that seasonal rates, where you generate more revenue in peak seasons, can be less volatile because peak demand can be less volatile. Next slide. Here's what it looks like in terms of the shape of uncertainty. So on the upper left, I have how the shape of uncertainty around annual sales volatility, which is plus or minus 7%. You know that if we look at how that translates into what the shape of uncertainty is around revenue, it's about plus or minus 6%. This is because some of the revenue is fixed. And around cost, it's even less. Note that's because the fixed costs are even the bigger portion. However, when you take the difference between them, because those two things wiggle together, we have a smaller amount. You need to look at this, and definitely you should not be celebrating that the short-term uncertainty looks manageable, because it can accrete and accumulate over time. Next slide. So in the long term, what's the long-term risk? There's a key difference between what the average forecasted sales are and what your likely sales are. This is attributable again to the law of averages, which we've adapted from Sam Savage in his work. He's a contributor to this handbook, his book on the law of averages. The first fact is that planning for the future is rife with uncertainties, and the second is that most people are not happy with that fact and prefer to think of the future in terms of average outcomes. The law of averages states that plans based on average assumptions are on average wrong. You'll note we have our balancing unicyclist here. Often a lot of financial planning is done based on average volumetric sales going forward. And if the cyclist stays on that path, he's safe. However, you can also observe that given the expected variability, that cyclist is going to be quite dead. Next slide. So I want to give a brief overview of this model. I will turn it over and let Bill Christensen illustrate it with an example. But I want to point out that this model was explicitly set up to dovetail with the handbook and to address in a user-friendly fashion what we perceived that the biggest flaws were of a typical water rate model. Typical water rate models assume that future sales are known with certainty and do not respond to price, weather, the economy, or supply shortages, which is to say, this is not the world we're living in. So specifically, this model is set up to address this. It addresses customer consumption variability, demand response, the predictable changes in sales, how customers respond to changes in the real price of water. It also has a very sophisticated section for planning revenue-neutral water rates during water shortages. It has a risk-theoretic simulation of revenue risks that we'll get to see illustrated. And you'll also note it's set up with forecasting over a 5-year time horizon, so you can have an understanding of how these risks accumulate. It also provides metrics on affordability. Next slide. So part of the output of this model is information on how a change in water rates will affect not only different customer classes, but different customers within a customer class. It has a fairly sophisticated section of before and after, comparing a pro forma change, what the bill impact is for customers across the entire customer class. This allows you to understand what political risks you're going to be running and how you might mitigate that, and that in turn can inform what the desirable water rate structure would be. Next slide. So the handbook goes into the accompanying fiscal policies, which are guidelines for financial management decisions, administrative procedures that cover the detailed steps needed to accomplish business processes. Administrative procedures are an important complement to financial policies because they ensure that day-to-day activities are in line with financial policies. So this is well documented in earlier work in the government financial review. Shane Kavanaugh was also kind enough to review parts of this. Next slide. There are three types of financial policies, including actionable policies that are linked to specific performance measures and dictate actions based on that. Performance measures that define what they are alone, with or without a prescribed course, or philosophical, defining general policy goals. Next slide. Financial planning is covered in the handbook and includes revenue and expense forecasting, revenue management and fiscal sustainability, including how you stabilize rates over time to provide predictable rates to your customers, and how you cope and hedge against uncertainty with adaptive rate design. It includes a section on revenue recovery mechanisms, cost recovery mechanisms. Both of those can narrow that shape of uncertainty and give you more certainty about what your expected net revenue will be. And it's also very much the case that sometimes, especially for long-term sustainability, there are sometimes transformational changes required for long-term efficiency. Different organizations are going to have to work differently, sometimes work together. And you see joint power authorities, other novel forms that have arisen to address the need for restructuring institutions to better meet the needs of communities and regions. Next slide. So there's an entire section in the handbook on implementation and public engagement. This is key because customer expectations have changed and evolved over time, and in general, I think it's the case that there are higher customer expectations today than there were even 5 or 10 years ago. So this particular section of the handbook has guidance on integrating collaborative planning, securing buy-in for water rate restructuring from within the water utility, starting at leadership, getting to yes, getting approval from elected officials, communicating both within the utility and outside the customers, how to treat the public as partners, both in problematic situations and in solutions that may require changes to financial structure and water rates. How clear signals can be provided and actually can empower customers. There are home water report services that have been used and tested recently that illustrate this, and there are case studies on this. Maintaining this dialogue with your customers over time, and guidance for fine-tuning water rate structures as a result of customer feedback. It also provides a message map for stakeholders. Next slide. So this is a screen capture of the first sheet of the Alliance for Water Efficiency Sales Forecasting and Rate Model. It is designed to be straightforward and user-friendly. It requires the least data possible. Anyone who's used a water rate model has usually had to work with customer consumption data. That's not new. What is new about this is being able to incorporate things like weather variability and even sales growth variability. So it does require and give tools for being able to explore how different kinds of uncertainty will affect financial planning. So I note even on the splash screen the different things that the sales forecasting and rate model addresses, customer consumption variability, demand response to changes in water rates, drought pricing. This is something that can be done, is completely forecastable in many parts of the U.S. and needs to be done. It does this within a rigorous context of probability management, and I'll put in a gratuitous plug for probabilitymanagement.org if you would like more information on that from a different nonprofit. And fiscal sustainability, about which government officers have certainly had a lot to say in the last 6 years since the Great Recession, the worst of the last 2 years. So there are 2 different modules to this model. One that focuses on rate design. You're not required to use the revenue simulation module, so you can use them separately. And let's see, I'll move on to the next slide and give just a few more screen captures before I turn it over to Bill. I mentioned the different things addressed here. Next slide. We took a look at some of the bill impacts. These are other metrics as opposed to a distributional graph. Next slide. This is a screen capture for designing drought rates. When you get here, I want you to wake up and look at how water rates may need to be different during a drought when Bill's going through the example. Next slide. So this is a screen capture of how water rates change due to variable weather. You'll note the sequence where you see the dive at the bottom was 1991, which used to be referred to as the longest drought of record, and now the climate scientists are referring to it as a mini drought. So next slide. There's a structure for drought pricing. This model leads you through it. Next slide. Focuses in on this drought in 1991. So when you can put this kind of information graphic in front of decision makers, it's a lot easier to expose what the consequences are of unavoidable water sales variability. It's important to be able to communicate kind of consequences between different alternatives. So I hope I've gotten your attention for the model, and with that, I'll turn it over to Bill Christensen. Take it away, Bill.
Thank you, Tom. My name is Bill Christensen. I work with the Alliance for Water Efficiency, and I'll be giving you a quick tour today of the AWE sales forecasting and rate model. And on your screen now, you should be seeing a Microsoft Excel file. That's how the model's packaged. So if you have Microsoft Excel, you can run it. Right now we're looking at the overview and instruction screen, and it contains details about the forecasting model, some different data requirements, input data that's required, and how to save rate designs. And it also includes this great demo at the bottom. So when you download the model and get it on your computer, I recommend running this demonstration so you can see the model populated with data, because a blank model is often hard to approach and understand. So I'm going to click that button, which will load the demo, and it's going to warn me that it's going to overwrite everything, and I'm okay with that because we want to see this demonstration. And I'll click OK, and you may see this link at the bottom of the page, and you'll see that throughout the model. There are links you can use to navigate from sheet to sheet, or if you're familiar with Excel, you can just use the navigation from sheet to sheet down below. So I'm going to click over to the model setup sheet, and it starts asking you for some inputs here. And the first is the bill tabulation year. So to set up the model, we'll select 2012. That's the year we have bill tabulations for and what we've selected. And I'll get into the bill tabulation screen a couple sheets from here and talk more about bill tabulations. And then you set your billing units, and you can choose between 100 cubic feet, 1,000 gallons, or kiloliters, and select from that. So I'll switch it back to CCF for our example. And then, as Tom has mentioned, the model incorporates a lot of weather data. So you specify whether you want your precipitation to be in inches or centimeters, and your temperature, whether you want it to be in Fahrenheit or Celsius. Next, in relation to weather and consumption, you specify your off-peak and your peak season. So again, you can select from a drop-down list, and you can see it's set to October now, but if I move it to September, the number of months automatically changes to 8, and the peak season changed months as well. So when I change it back, you'll see the August will change to September. So a lot of things happen in this model on the fly, which is a very nice part of it. And then the fourth step on this worksheet is to enter your maximum to minimum month production ratio, which is just your maximum months production divided by your minimum month production. And you can see this note here that it recommends that you use several recent years and enter the average of those results. You don't want to enter a maximum to minimum production ratio for a year when you had a drought or a year when you had a lot of precipitation, making demand patterns abnormal. And then the next step is to enter your customer classes. In the model, you can enter up to 6 classes, and in this example, we have 4. But just to show you how this works, I'm going to add an additional one. So I changed it from 4 to 5, and I'm going to type in other, just for example purposes. And you can see we now have 5 classifications. I'm going to change it back to 4. And you now see that that went back to not in use. And this is a great time to point out that when you see these shaded cells, it's simply part of the model that's not being utilized. So those classifications are not being used. And next, you enter median household income for your service area. And you also select the customer class that represents your primary residential sector. So here we're selecting single family as our primary. And now we're shifting over to the rate design module. And you may notice the red tab that's over on the overview, as well as this rate design module. And we'll see that again later as I step through the model. And those sheets represent instructional worksheets that give you an overview and tell you about the various modules in the model. So I'm not going to read from this. I'll skip through for time. And here we are at the bill tabulation worksheet. So on this sheet, you enter for every customer class the off-peak and peak season bill tabulations for the year selected. So in this example, we selected 2012 as our bill tabulation year. And you enter the number of bills that fall into a particular usage bin. So we have our usage bin here, and you can see the row 17 is 0 CCF. So there were actually some customers, or some bills, rather, that were billed at 0 CCF. And then it counts up, all the way to many, many CCF. So I won't scroll to the bottom of that, but you can see that you enter that for off-peak and peak season. I think it's particularly interesting, and I'll come back to the example that in landscape, you definitely see the big difference in that off-peak and peak season. So once you enter your bill tabulations, you start on the customer service charges worksheet. And here you start out with the first step by entering the number of accounts by both meter size and by customer class. So as an example, in the single family customer class, we've entered approximately 52,000 accounts that have 5/8 inch meter and are single family. There are some additional single family accounts that for some reason have a larger meter. And then you'll see more variability when you get into things like CII, where they have larger meters. So you break that out by account and meter, and then you move down to enter your service charges and the billing frequency. So I'm going to switch this from bi-monthly to monthly, just to show you that it automatically changes the bills per year. And you can select monthly, bi-monthly, or quarterly. And for this particular example, we're looking at service charges on a bi-monthly basis. So you enter the current service charges for your customers by meter size, and then you enter the proposed. So if you want to propose changes and see what that will do to your revenue, you can do that here, and you do it for each customer class by meter. For this example starting out, we're going to leave the proposed service charges the same. If we have time, we'll experiment with changing those. And so this is where, for me, the real fun begins, and this is where you get to design water rates and see what those impacts will be. The first step, as Tom talked about, demand elasticity, particularly response to price, that if you raise price, customers are likely to respond to that by lowering their water use and subsequently lowering their water bills. So the model comes with this table of recommended short-run elasticity values that you can select from, or perhaps your service area has conducted a study and you have an elasticity value that you use. But you enter for each customer class an off-peak and peak elasticity value. And again, the elasticity measures the percentage change in demand given a 1% change in price. So that's what these values represent. And you might notice this button over to the right that says Save Load Rates. So this is where you can experiment with different rates and see, how they compare. So I'm going to load this example called volumetric increase. And it's going to warn again that I'm overwriting data, and that's okay. And so it loaded a scenario. And you may notice here that there's now a tiered rate structure, and the current rates are uniform rates. And so we're now looking at the impact of adding a tiered rate structure to the single family and landscape class. So I'm going to go down the worksheet and just show you how it's set up. You can see single family here, multifamily, CII, and landscape. And those are the customer classes we selected for this particular example. And you change in the proposed rates what your new rates will be for both the off-peak and peak season. If you want to have a seasonal rate, you can enter it there. For this example, we're going to keep our rates the same in the off-peak and peak season. But like I said, we are adding those tiers in the single family and landscape. In the multifamily sector, we've added a 10% increase to the uniform rate, but kept them uniform. And for CII, we've kept the rates the same. And this is for illustrative purposes, and as we go through the example, you'll see some reasoning for that in the graphs that are produced. And so if I scroll to the right, it shows the current rates and what the annual sales volume would be and the proposed annual sales volume. So you can see in the single-family sector, by adding this new tiered system and changing the rates, the model's predicting a reduction in sales volume by 5.7%. However, if we look at the revenue is actually expected to increase by 18.4%. And we can scroll down and see how these changes affect each of the customer classes. And remember, we didn't make any change to the CII, so the sales volume is predicted to not change, and the revenue is also predicted to stay the same. Whereas in the multifamily, we had a 10% increase, which is projected to reduce sales volume a bit, but because the rates went up, annual revenue is actually expected to increase. And then at the bottom of the worksheet, you can see a total for all of the sectors. And to the right, you can see all of this information graphically. Graphics are always great, for portraying what's going on. And I also want to demonstrate that, we set up this tiered rate structure, and it's got 5 blocks, which is the maximum allowed by the model. But we may want to keep it simpler and say we only want 4 blocks. So we can see how the blocks are broken out, 5, 10, 15, 20, 25. And if we want to just have 4 blocks, what we can do is take this 25 block and just make it 20. And then I'm going to change this rate to 450 instead of 425 per CCF. And I'll change this one to 450 as well. And that's effectively made it a 4-block structure. So the model gives you that flexibility, and you can see the changes on the fly. So it's already calculated the difference in sales volume and the change in revenue. And so I will scroll to the bottom, and Tom, discussed this part, the bill impacts, and it shows you the average annual water service cost under the current and proposed rates, and the median annual water service costs under current and proposed rates. This chart to the right, where I'm hovering my cursor, also shows the current and proposed affordability index. So in this case, we're not seeing a large increase. It's slight from 1.2% to 1.3, so not a huge impact in terms of affordability. But if we want to see how the bills change graphically, we can scroll to the bottom and select a class and look at the bill impacts. And we're on single family now, and you can see how that's distributed. A percent of bills, 33% of bills are expected to not increase by more than 5%. And then you can see down the line 5 to 10%, 10 to 15, and what those impacts may be. Now let's look at CII, where we made no change. All of the bills are expected to essentially stay the same. Multifamily, less of a distribution because we really just had that 10% increase in the rate. So you can really see where those impacts are based on your decisions. So I will move to the next sheet, and this again shows the bill impacts for the different customer classes. So we have single family, multifamily, and landscape. And it shows the percentage of bills on the x-axis down here, and then the percent change in service and volume charges. So you can see that out by the time we get to 100%, none of the bills are expected to increase by more than 35%. And the bills out here that would be increasing by that much would be high water users, high peak water users. And you can see 50% of the bills are expected to increase less than 15%, where I'm hovering now. An interesting chart is the landscape chart, where we introduced a tiered rate structure and we effectively increased the rates, but you see 30% of the bills have no change. And that's, if you remember when we were on the bill tabulation worksheet, a lot of those, because they're landscape customers, aren't using water in the off-peak season. So those bills in the off-peak season are not going to increase. So I need to speed up because of time, so I'm going to switch over to the drought sheets. And here you can specify your curtailment levels for various stages of drought. Where I'm hovering now, you can see in stage 1, this is what the water provider is going to ask of its single-family customers, a 10% reduction in water use, and same for multifamily. For the CII and landscape in stage 1, it's 0%. And then you can see how that changes for stage 2 and stage 3 and stage 4. And at the bottom of this table, the model asks you to enter your expected compliance. So if you expect 80% of your customers are going to comply, it'll effectively multiply these savings you're asking for by that 80%. And similar to the rate design worksheet we just worked on, this step 4, design water rates, now we can design water rates for various stages of drought. So I'm going to select stage 2, and it shows our proposed rates. It just brings those over from the worksheet. And we have choices here. We could manually change these rates and see what the impact to sales volume will be if I scroll over to the right. But what's really cool about this model is it allows you to use Microsoft Excel's goal seek function to find revenue neutral rates. And you have an option. You can make each customer class revenue neutral, or you can make all of the classes grouped together revenue neutral. There's also this table at the bottom that gives you the option to say what blocks you want to adjust or leave. So this water utility may decide we're not going to adjust our first block in the tier. We want to leave that. That's non-discretionary water, and we don't want to penalize people for that with an increased rate. So we're going to leave that. And then you can click Find Revenue Neutral Rates. And it warned about overriding what we had. And you can see it generated these new rates. Before they were populated with our proposed rates, and now you can see they've been adjusted. And if I scroll over to the right, you can see annual sales volume decreases by 15%, but that the annual sales revenue is relatively neutral. And so now I'm going to click over to the revenue simulation module. This worksheet describes it and is great to get you started. As you can see, it has that red tab, so you know you're on a sheet with some good overview information. But the first thing you need to do to get the simulation going is enter weather data. You can enter up to 90 years of data, and it's recommended that you enter a minimum of 15 years. And you select your most recent year of data, and then you're asked to enter monthly precipitation totals, as well as average daily maximum temperature for those years that you have information for. And what's also really cool is if I scroll to the right, you can select if any of those years, if you were in a drought stage, and then the simulation module can use that to determine effects of weather on demand and what stage you were in and what those reductions would be. So once that is set up, you enter another couple inputs such as your expected growth rates, so your lower expected and upper rates of growth for each customer class. And it gives you some options on how you want that distribution to be in terms of the likelihood of those expected growth rates, and then whether or not you think there's a chance the lower and upper bounds could be exceeded. I don't want to get too into detail with that because of time. And then you specify the likelihood of restrictions. So you can use that data we just entered where we marked our weather data saying, yes, we were in a drought in this year, or you can use drought stage probabilities. And so here are some probabilities for various stages of drought, saying 90% of the time we're not in a drought, we're in stage 0, and 5% of the time in the past we've been in stage 1.
So, Bill, I'm going to recommend that we turn this over to Megan. We did have folks already see in the GIF the result of the simulation. They'll just have to trust us that the next sheet has a really cool button on it.
Yeah, absolutely. Yeah, you did show that. You did show that animation, so thank you for doing that. And if you have any questions about the model after you download it, please don't hesitate to give us a call, and we'll get you set. So Megan, I will turn it over to you.
Great, thank you, Bill. This is Megan Sherry. I'm a manager of special projects here at the Alliance for Water Efficiency. And we just wanted to wrap up the webinar by sharing some additional resources that we've developed as part of this effort. We know that there's much more to the challenge of financing sustainable water than can be contained or addressed in a single document, and our landscape is constantly evolving. So again, we wanted to just draw your attention to some additional new resources that you may find interesting. Next slide. So one issue we became interested in not too long ago was this issue of weather risk, which has been mentioned and discussed repeatedly throughout this discussion. We're seeing that variable weather, specifically wide swings between wet years and dry years, or persistent weather conditions like droughts, can cause significant damage to revenue. To revenue projections or cause revenue shortfalls. In other sectors such as agriculture and energy, they've long used actually market-based financial instruments to protect themselves against some of those potential costs related to volatile weather. specifically, it's even been used in municipal contexts in the example of snow removal insurance, which has been purchased by municipalities to sort of protect themselves against excessive costs related with heavy precipitation. So we wanted to take a look at whether this was a solution that could also work for water utilities, and we recently published a white paper that explores what kind of products are available to utilities to manage some of that weather-related revenue risk. And that paper is available at www.financingsustainablewater.org, which we'll talk about in just a second. Next slide. As part of this initiative, we also recognize that it's really important to share lessons learned and best practices from utilities that have tackled these challenges with new solutions, and to glean insights from those. So throughout these resources, we've identified new real-world examples that we've woven, again, throughout the different resources. Some of the topics that these new case studies and examples cover are successful public engagement and implementation strategies. We've also looked at utilities that have combined volumetric rates with long-term planning to address some of their fiscal sustainability challenges. Budget-based rates we know are of great interest, and we're working on case studies that sort of chronicle utilities that have successfully designed budget-based rates that have achieved revenue stability and how, as well as policies that support fiscal sustainability and what specifically do those policies look like. So these different examples are available in the form of full case studies that are available for download on financingsustainablewater.org, as well as throughout the handbook as you're exploring different topics. Next slide, please. So part of this project was to create a place where utility managers and other stakeholders could easily access information related to these topics that we've been discussing. Marianne mentioned our new microsite, financingsustainablewater.org, which is now live and makes both the handbook and the model available for very simple download. As you'll see on the capture here, there are clear buttons to access both of those resources as well as their supporting appendices and user guides. And you're just asked to complete a simple registration form so that we can make sure that we inform you when there are new versions available. So again, this website was created to house these resources, but also bring together relevant resources in one place that touch different aspects of financing sustainable water. Knowing that this issue also touches many stakeholder groups, it also provides dedicated information to that may be of interest for elected officials interested in this issue, concerned citizens even, and the media, knowing that these are all important stakeholder groups that utilities need to work with and communicate with throughout a rate change or and rate overhaul. We also wanted this website to be a dynamic source of information with fresh content to reflect a very rapidly evolving issue. So we do encourage you to check it out and to return frequently for new resources, blog posts on topical issues, and to sign up for the AWE newsletter, which is available at the bottom of the site, to receive regular updates on new content on the site. Next slide, please. The site also contains a resource search, which is very similar to our resource library located on the allianceforwaterefficiency.org site. We know there are many organizations working on solutions to these challenges, and so our intent here is to again provide utility managers and other different stakeholders looking at this issue an easy way to search for relevant resources. And so you can see a quick screenshot of it here. It's available from the homepage of financingsustainablewater.org, and you can use different filters such as topic, user audience, and even geographical location, as well as a keyword search to look for matching resources if you're interested in a specific topic. So we encourage you to take a look, provide us with feedback, and let us know if there are other resources you'd like to see added here. Next slide. In the final section, we want to, again, just give you a preview of what's coming next as part of this initiative, because, again, we want to continually keep this site updated with new materials, and we just wanted to run through what's coming down the line and opportunities to get involved and access additional education. Next slide, Bill. So we will be working in several regions over the next year to go in depth on resources. If you're in Texas or California, specifically, we do have workshops planned for this fall. And again, I encourage you to sign up for our newsletter or take a keep an eye open for news coming from your local organizations on these workshops, as there may be an opportunity to attend. We are also partnering with utilities who are interested in really working with us to use the model and to test out a different rate structure. So if that's something you're interested in, we encourage you to contact us. We're also looking at this as a tool that will be updated and enhanced over time. So we're also looking for feedback from managers who are using it on ideas that could improve the model, make it more valuable, that we can incorporate into future versions. We know that many utilities may be interested in bringing multiple employees up to speed on this tool, ensure that teams are proficient in model functionality. The Alliance for Water Efficiency is available to provide technical assistance and also more in-depth training services for our members. So if you are experiencing any difficulties, have questions about the model, or are interested in some of these training services, there are contact us forms throughout the website. And we've also provided Bill's email address here, and we encourage you to get in touch with us. Next slide, please. Also, we are working on a number of different new resources that will, again, continue to keep the site fresh and touch different layers of this issue. Keep an eye out on the site for video tutorials for the model, which will be coming out in the next few months. We are finalizing a few new case studies that, again, will be uploaded to the site for you to access. Specifically, we're looking at customizable messaging that utilities can take and adapt to their local context and use for different stakeholders, as well as multimedia resources such as an animated video that can help educate consumers or other stakeholders on some of these issues related to rising costs and resource efficiency. So again, I encourage you to keep an eye out on the site for new content. Next slide, please. And so in closing, I will pass it over to Marianne to conclude the webinar today.
Thank you. I would be remiss if I didn't conclude the webinar by thanking our initiative, project sponsors, and funders. All of this work was made possible by grants from the Walton Family Foundation, from the California Water Foundation, and from the Water Research Foundation. So we want to acknowledge our funders' support and recognize that without their funding, we never would have been able to have provided these tools to you. So at this point, we're ready to go to our questions. I understand from Jeffrey that we do have some. If you haven't yet typed in your question, you can click on that orange box with the white arrow, open the dialog box, and type in your question. And while people are doing that, let me just let you know that a PDF of this presentation will be posted on our AWE webinars page. And we will be also posting the recorded webinar once we clean the recording and get it ready for posting. We will probably also cross-post it on the financingsustainablewater.org webpage as well. So Megan has made clear how the website is structured. You can download the handbook and model free of charge at financingsustainablewater.org. There's no cost to it. We just need to know who you are so that when there are changes and updates, we can get them to you. And if you are a regular attendee of our Alliance for Water Efficiency webinars, save the date of October 16th. We will be putting together a webinar on safety and efficiency in building water systems, and we'll be talking specifically about the issues of Legionella and pathogen growth in systems and the role of water efficiency in those. So at this point, I'd like to turn it over to Jeffrey, who will go through the list of questions that we have received.
Wonderful. Thanks, Marianne. We actually have a number of questions, all at this point relating to the model, and came in when Bill was speaking. So here's question number 1. Does the model also enable the user to evaluate sewer rate changes?
Let's see. This is Tom Chestnut. I'll jump in on this. If the sewer utility recovers a part of their revenue through a volumetric charge on potable water, there would be applicability. The model was not set up explicitly to handle the different designs that many wastewater agencies use to set volumetric sewer charges. But I will state that it does have applicability for any rate structure that is predicated on volumetric potable water consumption. So specifically, sewer is often set on the winter period. You can do peak pricing where the off-peak period contains your lowest winter months that you're using, and the model could be used for that.
Wonderful. Thank you, Tom. Second question is, where did the elasticity estimates come from? Isn't there a lot of regions' systems variability in these that should be taken into consideration?
This is Tom jumping in again, and Bill, shut me up if I talk too long about elasticity. That's a dangerous question to throw on because I'm known to prattle on. But elasticity is a user-controlled parameter. So we do provide recommendations. We also believe that users should adapt it to their area. The key note is that you're looking for a short-run price response, not a long-run price response. And the vast preponderance of studies in the literature yield long-run price response where things end up ultimately. So caveat lector, but that is a user-controlled parameter.
Okay, wonderful. Thank you. Next question again on the model. Is there a way to take into account differential impacts across income groups, high income versus low income?
Right now, this is Captain Blitter again. The way to enact that would be to take your customer class, say single-family residential or multiple-family residential, it would be a residential class, and break it into 2 parts, 2 pseudo-classes, a low-income multiple-family and a not low-income multiple-family. That is the way you would handle that right now using the current structure of the AWE's sales forecasting and rate model. Over to you.
Okay, thank you. Is the user able to enter in the spreadsheet comments, documentation that describe the specific sources of data used in the model?
I love that. So the model is open source. It's not locked down. That has advantages and disadvantages, but one of the advantages is you can enter in comments and notes to your heart's delight. You can insert sheets. We recommend keeping a change log in it and keeping track of it. So some of these are modeling practices which do vary depending on the water utility, but the model is very flexible. It's open source, so it can be adapted. Back at you.
Wonderful, thanks. Follow up on the question relating to sewer rates. Does the model enable water and sewer rates to be modeled concurrently, thereby enabling the user to quickly see the effects on the bundled bill and the total utility revenue picture?
Right now, it's not labeled that way. You would have to enact it virtually by defining a customer class of sewer customers. So it is not designed for having separate labels for water and wastewater, comma. Right now, though, I know Mary Ann would love to sponsor a project that does so. Back at you.
Thanks, Tom. Can weather data be imported in the model?
Absolutely, and there's a fantastic user guide that accompanies the model that walks you step by step. There is, the NOAA has a website that's vastly improved and really makes it a lot easier to do that now with a dozen clicks instead of several hundred. The thing you do need to be careful for is checking your units. Depending on how your browser is set, it may provide metric units, but that's, again, under user control and fairly easy to convert back.
Thank you. The question here is about affordability index, questioning what is it based on, what information do you need to enter into the model regarding that?
If you want the, right now, it will display detailed information by customer class. If you want to know how low-income customers are affected, you need to have the knowledge of which of your customers are low-income. There's no way to do that otherwise. If you have that information, you can segment them out as a pseudo-customer class. Back to you.
Thank you. Can water budget-based rates be modeled?
They can, but it would require custom adaptation of this model. That said, it is open source, and anyone who has done or is looking to do a water budget-based rate structure definitely is not afraid of customization.
So maybe relating to customization, is there any way the model can be tailored for wholesale rate analysis?
Let's see. Only in a clunky fashion. So many wholesale water utilities sell to a much more limited number of retailers who are in fact their water customers. This model is really set up for retail customer water rate design and implementation. So I would not recommend that.
Okay, thank you. Can the AWE conservation tracking tool be hooked up or into the rate model?
I have used output from the AWE water conservation tracking tool to define both passive conservation and the water savings from passive conservation, that is from the plumbing code, and to get a quantitative measure of the water savings you expect from your active water use efficiency or conservation programs. And both of those can be used to a decrement of some kind of more simplistic water sales forecast. So that is definitely something that can be informative for making this more realistic.
Thank you. Does the model evaluate ROI?
So I'll define the term return on investment. And I think you would have to be careful to specify both what the cost of your investment in water rate reform would include and how you would quantify the benefits. So I don't think you will find, if you do a search, the letters ROI in there right now. I think that would have to be done externally.
Okay, thank you. Does the model have factors for number of people who live on a meter or the meter?
if you have unmetered connections, the model does have a place for fixed revenue generated from meter charges. They would not appear, and you would not want them to appear, as volumetric sales, because you would not be, since you don't meter them, you don't know what they consume. So you wouldn't even have that information. What you can do, though, is model a growth in your metered connections. So metered connections can be allowed to grow over time. And in that way, by having your existing unmetered connections in the fixed revenue, you can model a shift towards volumetric revenue generation on a forward-looking basis.
Thank you. And the last question I have here is, does the model include long-term demand forecasting? If so, does it include a Monte Carlo simulation tool?
So the model is not a long-term water demand forecasting model. It does include Monte Carlo simulation. It does this for what is not generally classified as long-term. So a 5-year horizon is more of an intermediate term. So no to the first part of the question, yes to the second part.
Okay, wonderful. Thank you. There are no further questions.
Well, thank you to all of you who have stayed with us to the end of this webinar. We really appreciate your interest in this topic. We at the Alliance for Water Efficiency are very hopeful that we have provided some tools and resources that are going to help navigate this landmine of revenue stability, and we look forward to continuing to do more work in this area and to bring you additional resources and information. So if you're not already connected to the Alliance for Water Efficiency by our email list and as a member, please get in touch with us. Let us know how we can continue to have further dialogue with you about water efficient rates and revenue stability. They are not incompatible objectives, and we are dedicating ourselves to proving it true. So thank you very much for your participation in this webinar, and we'll catch you next time.